Good morning all. Many thanks for taking the time out to collaborate on our webinar on using data to predict and prevent leakage. Our plan for the session this morning is to set the scene for all things leakage, give you an overview of our current solution, engage your appetite and interest in collaborating with us to develop our roadmap for the solution going forward. I'm Vicky White, a Senior Account Manager in Utilities here at One Spatial. We've also got Jeremy Heath, Innovation Manager at SES Water and UKWIR's Leakage Programme Lead on the webinar, who will give you an overview of the recent leakage report and current challenges. My colleague Rose will go through our current leakage solution with you, and we'll have some polls as we go along, followed by any questions and answers at the end. Quick housekeeping in that we will record and share this webinar with you, and we'll be producing a follow-up survey that we'd love you to fill in if you've got time. If you've got any questions as we go through, please write them in the questions box. And with that, I will hand over to Jeremy.
Thank you kindly, and I'm afraid I can't share my picture for some reason, but you're not missing out on much. So look, what I'm going to do is I'm just going to take you through why leakage is really important at the moment. Okay, so you're probably aware that in the UK over the last 5 years, all of the water companies have had a huge commitment in terms of driving down their leakage, and this has come from our regulator. Up until recently, a lot of companies were doing or were working towards their economic level of leakage, okay, where it's costing you as much to fix it as you get in benefit, okay. But because of climate change, because of the various demands, that's kind of gone out the window. And now every company is being told, look, no, we really need to drive leakage down a lot. And so all of the water companies in the UK are on 15% or more reductions over this AMP period. And that is very, very challenging indeed. Very challenging. And you can see here on the graph what's been happening to leakage over the last 20 years or so. And you can see the big dramatic drops at the beginning, and then it's been carrying on at that relatively steady level, okay, the sustainable economic level of leakage. And then we get that orange bit, which is the big reductions we're going through at the moment. What we've been doing is looking forward and going, okay, where does that go? Okay, where are we going to be taking leakage going forward? And it's going to carry on going down, as you can see. Okay, so that's been driven by two things, and you'll see on the top there the PIC and the NIC. So the PIC is the public interest commitment. That's from the English water companies, and effectively saying we will triple the rate of leakage reduction. And so that's that commitment there that you're seeing driving down in the next 5 years to 2030. Okay, going forward from the end of this AMP. So we're continuing to drive down leakage at that steep level. That is going to be even more challenging because a lot of companies at the moment are really approaching that level where they're going, we're really struggling to find, to send teams in to find leaks in areas. It's becoming far more challenging. But then we've also got the NIC target, and the NIC is the National Infrastructure Commission. And they effectively said, look, we really need to see leakage halved by 2050, okay? So they've got a 50% reduction from the 2018 figures. That would take us down even lower. So this is going to be extremely challenging for the industry going forward. Leakage will remain a high priority for water companies for decades to come. Okay, let's go to the next slide. So what's the response to that? The response has been, as Water UK, as all of the water companies coming together, is to come up with a route map and say, okay, how do we achieve that? How do we come up with a methodology that says we can be confident at hitting that? And there's 3 phases here about how we built this route map. So number 1 is we looked at the kind of historical and international review. Okay, so we're around and going, okay, where's the best international best practice out there? Okay, historically, where have we been? What are the regulatory drivers there, and what's blocking us going forward? And there was a lot of kind of information gathering there of looking at the history and looking internationally at where the other people are and things like that, and how do we match up with them. It's always interesting when you do international comparisons. One of the things I have to say that quite annoys me is that in the UK, we include supply pipe and plumbing losses in terms of our leakage calculation, which the rest of the world don't. So always remember that when you look at a figure for leakage in the UK, it's probably overestimated by 1/3 if you're comparing that with the rest of the world, because we do include supply pipe leakage and plumbing losses in there as well. Okay, carrying on, there's a little bit of a beef from me there, but carrying on, phase 2 was the stakeholder workshops. Okay, and basically we got everybody that's involved in leakage, all the leakage practitioners, supply chain, water companies came together, and did some workshops where we actually sat down and said, okay, how do we go about meeting these targets? Where do we need to prioritize our work? And then that led into cost curve analysis and actually doing planning and modeling to say, okay, these are the kind of solutions we're going to be looking at going forward. Okay, next slide. Can you go back one? I think we kind of missed, there we go, thank you. Modeling leakage intervention. Okay, so about 3 or 4 years ago, I coined a term, PALM, okay, which stands for Prevent, Aware, Locate and Mend. And we said, this is how we should be managing leakage. We've got to prevent it, we've got to stop it breaking out in the first case, we've got to be really aware of it, and that's by awareness, we mean in our kind of DMA level. Okay, so typically 1,000 properties. We then need to be able to locate it really accurately, so that we don't get dry holes, so we can dig down on it, and then we need to be able to mend it. And I said at the time, in order to manage leakage, you've got to be good at all of those. And so in our modeling, we've been looking at all of those, and you can see some of the modeling here that we've been doing. And just on the left side, it's going, look, okay, there's a cost required to hold leakage at a fixed value. Okay, to reduce it, you need to be fixing the backlog of leaks and reducing the runtime of the ones that are coming out and preventing them as well. And effectively, you can see that kind of curve there. And it says, as you get closer and closer to that base level of leakage, okay, your costs are going to go up more and more and more. On the right-hand side, you can see some of the modeling that we were bringing in. And there you can see we do an intervention at the top there where we're going to increase the number of repairs, okay? So we go out there, we throw crews at it and say, okay, let's do that. And we can see what that would do with the model, okay? The one further down is to go, okay, what if I start to do a lot, if I give a lot more money in terms of my ALC and everything else like that, and how that's modeled. So we built up a whole series of models that would work together for us to be able to understand the costs and the benefits going forward. Next slide. And these are the kind of areas that we picked up and said, these are the things that we need to be looking at, yeah, and these are our interventions on leakage. So improved active leakage control, that's more feet on the ground effectively, okay? Optimizing your pressure management networks, okay? That's absolutely driving down the pressure to the lowest you can get it. Obviously, that can be quite contentious because customers sometimes don't like that. Improve repair techniques, how can we speed up the time it takes to repair a pipe? Smart metering, advanced data analytics. Certainly seeing some great results coming out from Thames and from Anglian with the work that they're doing there. Smart networks, an area where my own company's been heavily involved as well. Okay, the idea that we get far more information coming back from our network that we can actually be aware a lot quicker. Okay, progressive pipe rehabilitation. Okay, so starting to go out and do some major pipe rehabilitation, and it's an area in the UK that we're sadly lacking in. Currently, the average replacement rate across the UK water industry is between 0.2 and 0.3%. That needs to go a lot higher. And then adoption of customer supply pipes and supply pipe replacement. And with all of those, we looked at, okay, what's the effect on leakage that's going to have? Okay, next slide. Which leads us into adaptive pathways. And effectively what that says is every company will start to use those interventions. And for every company, it will be different about where they go to the next one. So you start off with your low hanging fruit, you know, your pressure optimization and things like that. And then you go into your next ones, your smarter networks and your mains rehabilitation processes and things like that. And with each of these ones, what will happen is a company will need to go, okay, here's where I am on this pathway at the moment. And when the cost outweighs the benefit, then I've got to jump onto the next one. And every company at the moment is starting to put together their own plan on how they will use those adaptive pathways going forward. Okay? Which then drives you into your process and says, okay, this is how I'm going to be driving down leakage overall. And so what you'll see is, firstly, we'll be doing that ALC bit, and then we'll be looking at optimum pressure management, going into smart networks, mains replacements, and mains and CSP. And it won't be that you are only doing in that area. You'll still be doing your ALC, you'll still be doing everything else. But what it's saying here is that the only way of driving leakage down at that point is to have a combination of techniques that includes these ones as well. Because if you're not relying upon, if you haven't got those ones, you're not going to be driving leakage down to the levels that it needs to go to. So as you can see, it's going to be a challenging program going forward. And I think final slide for me, there we go. So some key messages there, okay? Leakage since privatization, there's been a lot of work that's been going on, and we're now at the lowest level for 30 years. Okay, aspirations for 2030 and 2050 are achievable, but it's going to require a step change in funding. Okay, reducing risk will require key decisions to be made in the next year. So that's one of the things that we're talking with our regulators about, and how we make those decisions going forward as part of our asset management plan, and making the right decisions. We'll be adapting to the risks and challenges as they occur. And investment in innovation is a key enabler. Some of you know that's actually my job title. I'm an innovation manager, and one of the areas I focus on is leakage innovation. And that's because I recognize that that's really the only way that we're going to be able to get that 2050 goal in a way that's achievable, but also affordable to our customers. So there's going to be an awful lot of innovation coming through in this sector at the same time. There we go. There's a quick overview from me. Let me pass you back over to Vicky.
That's great. Thanks very much, Jeremy. I think the key thing that I pulled out of that sort of 5 to 10 minutes is leakage innovation, where I suppose everyone's got the same challenges, but different adaptive pathways, and innovating and collaboration will sort of bring us all together on this. So I think what we'll do for the rest of the webinar is I will give you an overview of our solution as it is at the moment. Rose will go through a demonstration, and then we'll bring Rose and Jeremy back online at the end to answer any questions that you've got as you go through, which you can type into the question box. So currently, you can see on the screen at the moment, our solution provides a pipe distribution network classified into high, medium, and low burst propensity as a heat map to better predict assets that are most likely to fail and result in product losses through leakage using geographical insights and machine learning. Our solution allows you to quickly identify the location of assets that are most at risk of leakage by recognizing patterns using a spectrum of artificial intelligence that can't be otherwise identified by traditional methods and tools, and to make sense of the proliferation of data, making it much easier to integrate more data sets for use in analytical assessments. But what's key here is the data, which sits at the heart of any organization. A lot of data is required to train machine learning models, and anyone doing this should ensure through our rules engine that data is clean, correct, and unbiased, so we don't teach the model the wrong thing. And we use this process to create our own model, but we also use the same rules engine on your data to verify it, clean it up, merge it, and combine it with different sources, and ensure that it's consistent, compliant, and complete. Rules-based systems can be used to encode this geospatial information into numbers used by machine learning processes, such as size, shape, proximity, or other geospatial interactions with the surrounding data. Neurosymbolic AI acknowledge that rules and machine learning combined are more powerful, as it allows the guiding logic of a person explicitly defining rules alongside the fuzzy inference benefits of machine learning from lots of data. By QAing these data inputs, the key is to be able to develop a system that learns and understands the unobservable and hidden relations between various structural properties of the network, such as the pipe material, along with other parameters that render a pipe vulnerable to leakage, such as its age, previous history of leaks, either for a similar material of the pipe or its location, length, diameter, or elevation of the install. By combining rules and machine learning algorithms across spatial, semi-spatial, and non-spatial feature engineering techniques, we create spatially conscious machine learning models which outperform non-spatial models when combined with advanced prediction techniques. And with that, I will hand you over to Rose to demo what we currently have.
Thanks, Vicky. That was very good introduction. So hi everyone, my name is Rose and I'm a pre-sales consultant at OneSpatial, and I'm going to be taking you through our leakage solution demo. So as we've heard from the discussion before, leakage is a big problem for the water industry. OneSpatial have developed a solution which can help identification of pipes which have a high probability of leakage, and I'm going to be demonstrating this to you today. I'm first going to do an introduction to our solution, followed by the demo, and then I'll recap with some of the key takeaways. Our solution has been designed with subject matter experts and combines a rules-based approach with machine learning. You'll also notice that our solution is cloud-based and has a very simple self-service interface. Allowing you to easily upload your data, track and be notified of its progress as it's being processed, and then download the results. We tell the rules engine how the data should be, which validates the data before calling our machine learning process. Our machine learning process scores all the individual pipes that you have uploaded, regardless of whether they're in a district metered area or a network zone. The results you download help you locate the pipes of high probability of leakage and saving time and resources by directing repair engineers to the right location. So this is an example output shown in ArcGIS Pro, which shows the heat map to identify priority areas. So where does our leakage solution fit in? We think there are two main use cases. We know that finding a leak can take a while, and using our solution, our goal is to reduce that by giving each pipe a score, which enables engineers to visit pipes with a high risk score first. Using this same output, it can be used to help prioritize strategic asset management of where to upgrade pipes of high probability of leakage first. So we're now going to have a quick poll. So in your webinar window, you should be able to see a poll question, which you should be able to see now. So as a stakeholder, as a stakeholder in leakage, what are you most interested in knowing? Locations of high leakage, locations of high potential for strategic renewals, locations of high leakage potential for reactive leak repairs, areas of change for smart meter pressure, so areas of change for smart meter networks, so has there been a change in usage, and or areas of change in pressure, so are you seeing reduced pressure somewhere, or other. So if you could take some time to choose the most appropriate answer for you, that would be much appreciated. Thank you. So it's interesting to see. So you should be able to see the results on your screen now, with 70% voting for leakage for strategic renewals. So I'm just going to start presenting again. I'm just going to take you through an example workflow. As a user, interested in knowing of where in a network has high leakage potential, this is the workflow they would follow. The Leakage Solution app is opened up in a browser, and the user is required to start a submission to upload data such as a shapefile for a DMA. This would automatically run through a process. This app lets the user know which stage the data is at. The data is first validated, tables are populated before being passed a machine learning module. And this is delivered back to the user where they can download a report and the data as a shapefile. I'm going to explain each of these steps during our demo. So we're just going to switch over to our video. Okay. Oh. Okay, so our Leakage Solution app is available through SaaS, and the app has been available through our self-service portal called One Data Gateway. This video is running on screen, has not been shortened, so you can see it happening in real time. So I've just uploaded a shapefile from my desktop, and that is just making sure that the data is uploaded, and we can now press go. Let the solution know where our data is, and these green ticks show that it conforms to a data model which is required by a solution. If your data did not conform, you have the option to quickly remap the data into the right schema. So once that is uploaded, once the data model has been validated, the data processing takes over. Under the hood, our rules engine loads and processes the pipe network data before feeding it through a machine learning module to give each pipe a burst prediction. The rules-based approach is used to cleanse and normalize the data, first populating the missing values and resolving the noise in the data, preparing it for the machine learning step. We've created a machine learning module for leak prediction using a deep learning API written in Python, which runs on top of machine learning platform TensorFlow. Our solution needs to be provided with pipe network, which includes the attribute of pipe material, age, recent repairs, and with additional spatial data derived using our rules engine. Our rules engine also calculates the CPP height, which is derived from an elevation model and is our pressure parameter derivative. We have done statistical modeling to decide which of the important data sets required to build our machine learning process. So what the model is doing here first is validating our data provided and running different processes related to the shapefiles and adding data to a table and calling the machine learning process. As you can see, it's run through the 18 steps of importing, validating, running machine learning model, and delivering results back to the user quite quickly. So that is now run, and the user will be able to download a summary submission of a PDF, which will show the data processed. So I've just downloaded that here. And if we open that, you can see all of the data that has been processed and what's happened to that data. The user can also download the shapefile, which is the output of the machine learning model, and is a pipe distribution network classified into a risk score of 1 to 5, where 5 is the highest burst potential for each pipe within that network. I'm just going to go back to my presentation, and we will start off. So I've got that result open in QGIS, but you could use this in, as this is a shapefile output, you could use this in any GIS system that you have. So if we explore this output, you can see the green areas which have low risk of leakage, but the orange and red areas have medium risk and high risk of leakage. So you can see how easy it is to identify these areas, and these should be prioritized for investigation. So why have we developed this solution? We know that leakage is a problem for the water industry, and finding leaks quickly helps to reduce impact to customers. There is also a financial incentive to have reduced loss of water, but also time spent looking for the asset which is leaking. Water is a natural resource where we must reduce leakage to meet environmental targets for the industry. So as a summary, a user wants to assess the pipe network to find locations at high risk of leakage. They have their pipe network, which includes key attribution of age of pipe, history of leaks, and pipe material. We then use additional spatial data, so proximity to road and rail, and we calculate the CPP, which then allows the user to download a heat map result. So we're just going to have time for another question, which should be on your screens shortly. There we go. Does your network data have the attributes of age of pipe, history of leaks, and pipe material? And please can you choose from the answers below? I'll just give you some time to fill out those polls. There we go. So it's interesting to see that 36% have the data, and there are some partial data sets as well. So thank you for participating. I'm just going to start sharing my screen again. So now that brings me to the end of my demo. If you have any questions, please post them in the window and we'll answer them at the end. I'm going to pass over to Vicky to see where we take our solution next.
Thanks, Rose. That's really useful, and I think it's given a great insight into where our solution is at the moment. But before I talk about where we're looking at taking the solution, let's look at how we got there. So we started out in 2018 or 2017 at the Northumbrian Water Innovation Festival, simply using our rules engine to produce a heat map for their Essex area that they're still using their GIS today. And then in 2020, we combined the machine learning approach into our solution and did a hackathon on consumption patterns with Anglian Water. So where next for us? We're considering tweaking the model to incorporate additional data sets such as real-time data from sensors and loggers or smart meter data, and perhaps look at consumption patterns or predicting supply pipes by inference or looking at DMA flow data. Can we do inference or modelling of student populations or the changing consumption patterns with the new hybrid working since COVID-19? And all of these are possible with data, our rules engine, and machine learning. OneSpatial is a company that's interested in innovating with data and technology and collaborating with other companies, and we'd really welcome your views. We've also been doing this for a long time, taking this approach to problem solving by working with our customers and data. And think about the possibilities of clean, validated data that can help with your sewer inference, network model, and building of your digital twin. Or even if you're thinking through how you approach migrating to new data models, such as the Esri utility network model. All of the above automated and artificial intelligence techniques can help you confidently migrate to these next generation systems. Improving the data manually take a long time. So our philosophy is to make some assumptions and automate, and use that to manage the risk on your projects. And this is where our rules-based approaches can come into their own. Test all these assumptions, use rules to test assumptions on data so that you can manage the risk. And lastly, it wouldn't be a presentation about data if we didn't mention data governance, quality, and ethics. And OneSpatial provide customers data provenance and risk ratings to data sets. For example, was data collected through survey or inferred through AI or other processes? We're often involved in the audit of all the data flow of cleaning, integrating, and transforming data, even if not in the decisions and actions taken from the data itself. However, we do adopt standard good practice behaviours and approaches in the work that we do to protect privacy and ensure cybersecurity. And these controls help us to ensure data and systems are worked on by authorised people to protect privacy. And our solution helps users understand impacts of data provenance via repeatable and traceable automation processes, so that decisions can be traced back to data sources. So in this webinar, Jeremy's very kindly set the scene for us. Rose has talked about our solution as is, and I've mentioned the to be, and to sort of keep the final poll going before we go to the questions and answers, could we have another poll question, please, about what data would make our solution more useful? And if you could tick all that apply, please. So we've got noise, pressure, consumption patterns derived from smart meter data, property or demographic data sets such as age or type of household, or student population, that type of thing, or if there's anything else as well. Just waiting for the results to come through. Oh, that's interesting. So there's a bit of everything really, not so much on the property and demographic data sets, but a lot on pressure and consumption patterns, and a bit on other, which should be good to figure out what those other data sets are. So if we can move on to the last slide, please. So what I'd like to say is thanks for spending half an hour and listening to us and participating in the polls as we've gone along. And if we could have a look to see if there's any questions in the chat. Pull up now. If Rose, could you turn your screen back on? And Jeremy, I don't think your screen's working, is it? But if you could turn your mic on, that would be appreciated.
Turn my mic on. Yep.
Great, thank you. So one for Jeremy. How feasible is it that tools like these will drive down leakage to the levels required?
Very feasible. So effectively, what we're looking at here is a suite of solutions. Okay, there's no one solution that's going to solve leakage. That's why we came up with that palm analogy. You need prevent, aware, locate, and mend. And the danger comes is everybody comes in and says, yeah, there's this kind of silver bullet that's just going to solve leakage. It's not there. Okay, but what there is solutions like this in company with other solutions as well. And it's going to be that kind of suite of tools that we have that's really going to be driving down leakage. And completely look at that. I love that presentation. Fantastic. Because for me, there's two real bits here. Number one is that prevent aspect of going, okay, where's that high propensity for burst? Because that's going to be starting to drive your mains replacements and everything else like that. But then also it's those field teams that are going, okay, I've got a 2,000 property DMA. Where do I start looking? And it's going to be driving down those awareness and location times as well, which is really important. We certainly know that if you can send a team to a specific area, it makes a huge difference. The problem that we're getting is we're losing a lot of that experience as older members of our teams retire, who just knew which part of a DMA to go to. That this kind of solution makes a huge difference for that.
That's great. Thanks, Jeremy. I think, as you say, there's no sort of one size fits all, is there? It's an amalgamation of lots of different tools to basically chuck everything at it and see if that helps.
It's really interesting. I think that sorry, Vicky, I carry on talking. You know me. I was really interested in the breadth of other information that people are seeing as important. And I think, yeah, the smart metering one is a big one that's going to be coming through. We're seeing a number of companies now looking at smart metering. And for me, the power of that is absolutely the integration into solutions like this, where it just increases your confidence. It just says it's more likely to be here. And all of these solutions are effectively, it's a risk-based solution that's saying, okay, we can't promise it's going to be in this road in this main, but the chances are high. And if we can get smart metering data in there, we can give you even higher chances in terms of finding these leaks. The other really interesting one is pressure, and it's really interesting. A number of companies are now starting to look at what we call non-acoustic methods, and it's bringing in those non-acoustic methods that will help tie down, exactly where you're seeing localized pressure drops, or if you're using satellite systems, you're seeing, kind of hotspots from the satellite systems, and you start to combine those data sets in as well to increase that confidence level.
Yeah, that's yeah, I suppose bringing in data from different sources like that could have been the other in the sort of questions that we asked, is looking at all the satellite imagery and how all that works. We've got a few more questions, so I'm just going to move on to one for Rose. And how easy is it to add new data sets to the solution?
Thanks, Vicky, and thanks for who asked that one. So it depends how clean the data is initially. So that's where our rules engine comes in. So we can clean the data and make sure that it's suitable for the machine learning step. So if you remember at the start of the demo where we imported that data, if it didn't conform to the data model, you could change the schema. So it can be pretty flexible with new data that can be added.
Thanks, Rose. I've got one which has been asked as, has there been a case study comparing the AI results of location of leakage to the reality of leakage in a DMA? I'm not sure if that's something that we've done, Vindaya, or whether Jeremy knows anything, if there has been a case study on that.
No, I'm just pausing for a second. There's been a lot of work going on, things like dry holes and things like that. I'm not aware. I'm aware of some companies that have done some ad hoc stuff where effectively they've done some random testing. That wasn't specifically about this solution, it was with other solutions that were effectively localizing leakage, and they did some blind testing against it and had a variety of results. It's one of the reasons, I think this is one of the issues that we do find is with the solutions coming out is that ability to compare and contrast them. We're doing a piece, so as I said, I'm UKWIR, the UK Water Industry Research Programme Lead on Leakage, and one of the pieces of work we're doing at the moment is looking at non-acoustic methods of leakage detection and how we can compare and contrast those. But as I said, if it wasn't working, companies wouldn't be using solutions like these. Certainly, I've not heard of companies that adopt a solution like this that then back away from it. Okay, And I think for me, that's a little bit of the proof of the pudding is in the eating, as we sometimes say in the UK, is the bit that once companies start to get this kind of level of data through, and certainly that's what we've seen here, is that once you start to get that level of data, it makes a sea change in terms of your ability to locate and your awareness times. And that's a huge advantage for any company. If we were in a steady state, if we were just trying to maintain leakage at an economic level, yeah, it's harder to justify solutions like this. For the next 30 years, we're going to be driving leakage down to unprecedented levels. Solutions like this will be absolutely required by everybody.
Thanks, Jeremy. Vindai, have you got anything to say on the case study side of things?
Actually, when we were creating this model, the existing network, the data that was available for us to actually, investigate the data and create this model, I've actually separated it out into test area and training area. So, and the test area, we had a past history of leakages, and the solution was working really good on that test area.
Thanks.
But as a case study for, no, we didn't get any other data after that.
It could be something that we sort of look to do in the future.
Yes.
Hang on, I've got another, well, I'll just pan up a minute. So we've got another question. A customer having its own, this is for you, Rose, a customer having its own leakage detection model, can he plug into one data gateway, which is our solution, to facilitate the data supply and data exchange and results?
Could you say that one again?
Yeah, so a customer having its own leakage detection model. So I mean, I think the answer is yes. So he has his own leakage detection model, and he can pull the data into one data gateway to facilitate the data supply and data exchange and results.
Yes, I'd sort of say that would work.
Yeah, because the data would be cleaned and it can be pulled into. Yeah. And then we've got a comment is just to say water companies are very reliant on insights around property and demographic data, and they use Acorn or Mosaic data. So yeah, that's what we've been looking at. We did a hack on them with Anglian Water, I think it was 2020, where we looked at supply patterns and number of households and whether they were a flat or whether they were a 5-bedroom house and how all that worked. So that was an interesting one as well.
I think, Vicky, let me just chip in there. I think that, and it's a really good data set. We use Acorn as well. I think the interesting one is hearing some presentations from Andrew at Thames when he talks about this, and he says there's no such thing as an average customer. And I think, the finding from Thames, and they've got, the most extensive smart metering network out there at the moment, is that even when you think you've got a good understanding of demographics, it's the outliers that are really driving usage patterns within areas. It's those customers that, you may say, okay, these customers act in this way, but there's a few outliers and they can have a huge effect upon your consumption. And I think, that ability to bring in that smart meter data into platforms like this will make a big difference, because it will start to help you understand what's going on at a DMA level. Where you've got a local gardening society and they all decide they're going to water at a certain time, and it starts to get you that kind of appreciation of what's going on, or an allotment or something like that, that can really drive different usage patterns within those areas. So yeah, I have to admit I'm optimistic. I think I am naturally an optimist, but I'm optimistic that as the smart meter rollouts occur across the UK, that data set will increasingly become one of the most highly valued data sets we've got in terms of leakage management.
Yeah, I agree. We can't share. We had to delete all the data after the hackathon, but the results were what we've talked about were really interesting. So I'd like to see how that works with the model. Hang on, I think we're just at the end of the questions now. So what I'd like to say is just thanks again for your time and participating today. Thanks very much to Jeremy, because I know he's a very busy man, for sparing his time. And thanks for Rose for preparing the demo. And your time for participating. And when the webinar closes, there'll be a link to a short survey, which we'll see if you're interested in just helping us out, thinking where we take our solution, which I can also send around. And do get in touch with us. You can see the utilities at onespatial.com email address, which will go directly to myself. And for any sort of further thoughts and questions. So yes, thanks very much for your time.